Hey everyone, welcome back to my channel. This is Vikas Singh Thakur, and in this video I'll be sharing a complete roadmap for you to getting started with robotics. And it is not always about starting something, it is also about finishing it. So I will be guiding you in 4 different stages. Each of these stages will be containing hardware and the software and a dedicated timeline so that you don't find yourself stuck on a single stage and you can cover as much as topic or as much as important topic as you can. So for the first stage, that is stage 1, that is the foundation stage. So here we need to understand the basics of IC, basics of electronics component, especially when we are talking about hardware. So here the basics of electronic components like resistor, capacitor, diodes and transistor is very important. Understanding different logic ICs like AND, OR, NOR, XOR, which is very important, especially the multiplexer and adder ICs. I have used this kind of multiplexer and adder a lot in my project, and there are bunch of application out there. So you need to get a basic understanding of how multiplexer and adder circuit work and how you can actually integrate that in your project. Next is the multimeter uses. Multimeter are very essential or very important tool that you need to have your hands on, and you need to get a basic understanding of how you can use that in your circuits. Next is the soldering basics. So soldering basics is very important because when you are working with the some basic prototyping or some bits and all, then you need to get understanding of soldering basic. Next is the object-oriented programming basic, that is OOPS sometimes we call it. So you need to get a basic understanding of how OOPS work, what are the basic inheritance, encapsulation, all the other the basic concept work under this. So you need to get a basic understanding of how all this work. Next is the control structure and logic building. So you need to get basic logic building cleared in your mind so that you can build different kind of logic. So initially you don't need to go up to very extensive logic. You need to build a basic logic first, then over the time everything, when you are working with the real project, everything will be automatic, so you don't need to rush a lot. Next is the code editor. So for the code editor, whatever the code editor you like for example, I usually use VS Code a lot. So you can go with the VS Code or other code editor if you want to. So you need to understand how a particular code editor work. Sometime these days also a lot of AI extensions and AI extension or co-pilots are there. So you can work those extra work with those extra AI features with your code editor. That is very great. Next is the Git basics. So Git basics is very important. So when we are talking about when you the file management or the code management and working with different projects and repositories, then Git basics is very important. And understanding of GitHub usage and building different repository and different project is also important. Next is the command line interface basic, that is CLI basics. So you need to get the basic command or the PWD, LS, all those kind of command. Basically when you are working with for example VS Code or your code editor, almost all the code editor got their terminal where you can actually practice all this command line interface or command line tools and all. Next is the basics of CAD tools. So for example, for the starter or the beginner, I would suggest go with the Tinkercad or the FreeCAD. FreeCAD, as the name suggests, it is a free software where you can actually simulate a particular design, or you can build your 3D model or some kind of thing. Or there are much better versions of CAD software out there, like Fusion 360 is also there, which is very basic, and it is very useful too. And I would suggest try to complete everything here on 70 days. So 70 days is more than sufficient, I could say, for understanding the basics here. And also don't try to rush a lot. So 70 days is more than enough. But if you are a student who is right now in your first semester, then I would suggest try to complete everything here in your first semester. And because there are lots of rush or lots of problems will be there, like for example you are getting some assignment, you are getting some peer pressure or teachers and all those kind of things. So you need to be very calm down here. Try to do one thing at a time, don't rush a lot. So this is stage 1, this is the foundation. Next is the stage 2. So here we are talking about microcontrollers and embedded system basic. So in the stage 2 we can see the hardware and the software here. So first we will be covering the hardware. So in the hardware, the microcontroller is very important, like understanding Arduino Uno, ESP32, ESP8266. There are multiples of multiple Arduino Unos or ESP32 versions are there. So you need to work on basic of microcontroller. So you need to get understanding of how PWM work, how the analog and digital signals, or how you can use or utilize this kind of thing. Next is the sensor integration. Sensor, there are a lot lot of sensor as I already told you. So try to go with a certain sensor kit for exploring multiple kind of sensor. Next is some important sensor are also there, like IMU sensor, which is I definitely suggest you to try to cover up this thing out, because when we are talking about advanced robotics, then this kind of sensor are very important. Next is the actuator. So here we are talking about basic actuator like DC motor, and there are different categories with the DC motor also, like DC motor with the encoder, through which you are actually getting the certain feed value back from your motor and certain thing. So you can go with the different kind of DC motor or DC motor with encoder. Next is the servo motor. Servo motor are highly used in robotics, especially in robot arm kind of thing. So you can go with servo motor. Next is the stepper motor. So stepper motor is work in very precise. For example, we are working on CNC or 3D printer kind of thing. Then understanding stepper motor and its working is very important. After that, next is the motor driver. So in the motor driver, there are lots of motor driver out there, but you need to just getting when you are starting with it, then I would suggest try to have your hands on with the L298N kind of motor driver. They are very cheap and very basic, but very useful too. So you can build some basic project and try to control DC motor with your microcontroller or certain kind of thing. So you can based on that you can explore multiple kind of the DC motor driver or stepper motor drivers ahead. Next is the power system. So power system, as I already told you about, try to have your understanding with the batteries and different kind of batteries and different parameter related to that particular battery. Here in the power system, you need to work with the power motor power supply management, voltage regulator, battery protection module like BMS and all those kind of things. After the power system, next is the communication protocol. So in the communication protocol, you need to get understanding of UART, I2C, Wi-Fi, SPI and all those kind of things. And after that, different communication protocols are there, like the Wi-Fi, Bluetooth, LoRa, that is long range, Zigbee for communicating with multiple devices at a time with a less amount of power consumption and all those. MQTT is also a very important concept that you need to work when you are especially working with the web socket and all those kind of things. So this kind of basic communication protocol are very helpful. After the the hardware part, next is the software part. We are talking about the stage 2 in the software part. So here you need to get understanding of Arduino IDE. Next is the platform IO. So Arduino IDE and platform IO is, I could say, the better version of Arduino IDE. Or I could say this is a kind of extension for your VS Code or code editor. So you can actually integrate platform IO, and instead of using Arduino IDE, you can go with the platform IO. After this, the next is the embedded C or C++ basic. So in the embedded C, as I already told you, instead of directly learning very advanced in the C or C++, you can actually implement that with the Arduino IDE, because Arduino IDE uses derivative of C or C++. So you can get a basic understanding and all the logic cleared in your mind. So next is the basic library usage and integration. You need to get a basic understanding of what are different libraries and how they are actually working. So over the when you are actually working on some project, then this will be automatic. So you need to actually get started with some project to understand different libraries and all. Next is the serial debugging. You need to it is a part of Arduino IDE or whatever the development environment you are working with. You can actually print out everything and you can actually check everything out. Next is the Python for robotics tool, like the OpenCV is there, MediaPipe is there, TensorFlow, like when we are talking about machine learning and AI kind of thing. And API integration is very important. Nowadays we are working with lots of projects where we want to integrate some AI tools and all. So we can work with the API usage basics. So after the stage 2, the software, and here I would say try to cover up everything in this, like the basic part in the 75 days. So 75 days is good enough for covering all the basics here. So after this stage 2, we are talking about the stage 3. So in this stage 3, we are going with the advanced embedded system and AI tools. So I would suggest try to cover up everything here in 140 days. So this is little bit advanced topics, I would say. That's why I have increased that the timeline here. So when we are talking about the hardware board, like STM32 boards, Raspberry Pi Pico, Raspberry Pi 0W. So Raspberry Pi 0W or 02W is only for those guys who are having budget constraint and really want to get started with some SBC or single board computer. Then you can go with the 0W, but I would definitely suggest try to go with the Pi 4 or 5 for better performance and overall the future project that you want to work with the great AI tools and all those. So you need to go with the Pi 4 or 5 for better computation. Next is the Jetson Nano. So Jetson Nano is another optional thing, I could say, because when we are talking about the budget, because lots of you cannot actually afford this. I can really understand, and I relate myself up to this stage. So I would suggest try to go with up to Raspberry Pi 4 or 5 kind of thing. After this, next is the AGI hardware. So in the AGI right now, we can say the AGI era is also going on, because we want everything to be running locally, like Olama or different LLMs are there that really need to work on your local computer. So you can actually explore different hardware tools that actually enhance this kind of thing. So Coral TPU by Google is one of the example here. Intel Movidius neural compute stick is also an example, but mostly I would suggest try to go with the Coral TPU kind of hardware accelerators. After this, the next is the advanced sensor. So advanced sensor here, as name suggests, advanced sensor. So when we are talking about some industrial grade technologies like industrial grade sensors and different devices, then LiDAR are very important tools. And after this, the stereo cameras. So stereo cameras are called the depth camera. Like for example, I have an Intel RealSense depth camera. So using that, we can actually map everything out, and we can actually simulate everything in the ROS or some different frameworks like that. So you need to get understanding of how all of these work. So after this, next is the GPS module. So when we are talking about some drone technology or some some autonomy in based on the GPS kind of system, so understanding different GPS module like PICSOC and integrating them with the different controllers like PICSOC and all those kind of things is very important. Next is advanced IMU. So when we are talking about 6 degree, 3 degree IMUs, there are more degree of, for example, 9 degree of freedom IMUs are there. So you need to get basic understanding of how IMUs work. After this, next is the computer vision. So when we are talking about the computer vision, this is very important. So in the computer vision, I would suggest try to go with the OpenCV or computer vision libraries. Get basic understanding of how you can integrate that with your SBC when we are talking about Raspberry Pi. So computer vision, like computer camera interface, image processing, object detection, edge interference. This is very important. In computer vision, I want to add extra thing here, that is VLM, vision language model. So using that, we are actually integrating LLM in our systems to identify everything and give us a smart output. So this is for the stage 3. And in the software part for the stage 3, I would definitely suggest go with the Linux fundamentals. So in the Linux fundamentals, you need to, Linux is operating system that is extensively used in industrial grade robotics, especially when we are talking about industries. So you need to get a fundamental of Linux, like, basic understanding of terminal, how the command line work, how different command works, how the file management, user management is there. You need to also get understanding of SSH usage when you are working with, especially with Raspberry Pi. You will be automatically going to face SSH usage over the timeline. After this, the package management, the package manager is there. Python, for example, for the robotics, when we are talking about robotics, then OpenCV and the VLMs, as I already told you about, vision language model. So these are very important too. And also getting basic understanding of TensorFlow or PyTorch. These are especially used in AI or ML kind of project. So getting basic understanding of how TensorFlow and PyTorch libraries work. So you need to work on this kind of project to get a better understanding of this. Next is the AI model deployment on edge devices. So for example, as I already told you about, there are lots of open source LLMs like Olama is there. So you can actually deploy that in your Raspberry Pi, and you can build some smart or cool project out there. Next is the electronics design. So here we are talking about the better professional way of designing everything, like in a prototype when we are talking about. So in the electronic device, I would say try to get started with the PCB design, basics PCB designing. And there are very easy tools out there, like for example Easy EDA or KiCad is there, which are almost free, and you can do a lot of better or professional work with this kind of tool. After this, the next is the mechanical design. So as we have already started with the the Tinkercad or the Fusion 360, you need to actually start implementing everything out there. Like for example, you can get to multiple different 3D printing services or PCB designing services like PCBWay or Next PCB is a great example. So you can explore different services and try to have your project a better go up to better level. After this, the 3D printing and different understanding of tolerance and fit and the size and all those kind of things. You need to get basic understanding of the mechanical design. After the third stage, as I have already told you, try to cover everything here in 140 days. After the third stage, the stage 4 is there. So here we are talking about robotic system and integration. So here we are talking about real life implementation. So for example, when we are talking about industrial sensor like encoders, lidar, depth camera, or SLAM, that is simultaneous localization and mapping. So here you need to get understanding of ROS. So basically the stage 4 is more dedicated to the ROS, that is robot operating system. So ROS is a very highly extensively used and industrial framework that is almost any kind of humanoid robot go with this task. And when we are talking about autonomy, lots of autonomy are actually working inside ROS framework. So you need to get basic understanding of this hardwares here, so you can get started with the robotics. So rotatory encoder, lidars, depth camera, SLAM sensors. So you can actually use depth camera and different kind of cameras to integrate that with the ROS. Next is the basic understanding of actuator, how the closed loop servo motors are actually working. So for example, as I told you about the normal servo motor, those are RC servo motor. And when we are talking about some advanced servo motor that is having a closed loop, that is actually giving you feedback on on a reverse. So you can actually work with this closed loop servo motor. Next is the BLDC motor. So BLDC motor are when we are talking about in robotics, so especially in the drones, so you need to get basic understanding of how BLDC actually work. Next is the robotic arm actuator. For example, when we are talking about some FOC kind of concept, so that is field oriented control kind of concept, then these are extensively used in robotics, especially when we are talking about the closed loop. So you need to get basic understanding of this kind of actuator. After this, the mechanical, when we are working on different designs, so you need to work on different chassis design, robot arm design, as we have already get basics on stage 3 about the designing or 3D designing tool. So you can actually start working on some basic robot prototyping and all. In the software part, I would suggest try to get started with the ROS or ROS2 basics like the node, topics, services, action parameters, and there are lots of different concepts here, so you need to get yourself covered up. So next is the robotics algorithm. So if, for example, when we are talking about SLAM, that is simultaneous localization and mapping. When we are talking about localization, path planning, motion control like inverse kinematics and all those kind of things. So you need to get a basic understanding of how all this works. Next is the simulation. So simulation is very important nowadays. When we are talking about real job or robotics job out there, lots of the companies are asking for digital twin understanding and all those kind of things. So you need to get basic understanding of different simulation tools out there. So for example, Gazebo, Arvis, and ISEXIM. Understanding of ISEXIM is very important. But then we need to work on different packages like MoveIt, Nav2, or sensor integration package. For example, when we are talking about lidars or SLAM, then we need to understand different package and how we can actually integrate that in our own project. Next is the advanced communication tool like DDS is there. Next is the RTPS, CAN bus. CAN bus is very important and very extensively used protocol for when we are talking about industrial grade motors and all those kind of things. So EtherCAT, CAN FT, these are more there are lots of advanced communication tool or protocols are there. Next is the digital robotics, when we are talking about the physical robotics and a digital twin of it. So for example, an industry want to deploy some robots in their industry, then what they actually do is they actually build a simulation or the entire simulation, or we call the digital twin or the digital the simulation of that entire factory, and try to deploy the robot, and they can actually check how they the robot could enhance their actually work and all. So you can go with the digital robotics, so in the simulation, hardware to software integration and all those kind of things. So these are the 4 stages here. So after the 4th stages, I would suggest try to go with multiple career path over all this stage 1, 2, and 3 and 4. So all of these stages will be containing multiple topics, multiple subtopics, and over the time you will be finding yourself curious about certain thing. For example, if you want to go into ROS development, and if you want to go into digital twin or some certain kind of embedded or software developer in robotics, then you can definitely explore a lot of things here. So this is all about this roadmap, and I have built an PDF and compressed PDF so that you can just print that out and stick that into your particular board or the workspace you are working on, so that you can check overall progress over the time. And this is all about this roadmap. And if you're liking the content here in my YouTube channel, then please do like and subscribe my channel. And if there's someone who is needing this kind of content, then please do share this with your friends. And this is all about this video. I am Vikas and I love robotics. See you on the next video. Till then, bye.